Welcome to our expert workshop on automated credential management with CCAM GridPass. You will receive valuable information designed especially for substation security, operation, and maintenance engineers. My name is François Simon. I'm happy to be your moderator for this webinar. Today, I'm giving you a virtual tour through this webinar for automated credential management with CCAM GridPass and SIPROTEC 5. And we have also prepared a hands-on session. We will start with the X509 certificates and its benefits. You will learn how to manage your public key infrastructure environment. You will then learn how to automate it and get to know how, not only some practical example and use cases, but also answer the frequently asked questions. And since we receive one question rather often, yes, we will record the webinar and make the recording and the slide available to all registered participants. If you already joined one of our last energy automation webinars, you already know the Q&A field in this application. Please type in your questions to the presenter, and we will be your voice and answer them directly after this presentation. And just in case you are in full mode screen, press Escape to see the Q&A. And now, let me introduce ourselves. Hussein is Product Lifecycle Manager for security domain of SIPROTEC protection equipment. He will be mainly conducting the presentation about EST and what Siemens offers in this regard. And I am François Simon. I am the promoter for cybersecurity in the scope of SIPROTEC and SICAM device. After the presentation is over, I will be presenting the hands-on session with EST. Hussein, the stage is yours.
Thank you, Simon. So good morning, afternoon, or evening to all around the globe from Nuremberg, Germany. In this webinar, I'm happy to talk about our new release feature EST, which is the abbreviation for Enrollment over Secure Transport. This is a protocol standardized in IEC 62351 for energy automation networks, which exactly reduces the time required for the commissioning and operation of your PKI infrastructure. Siemens offers EST protocol in a wide range of protocols product portfolio in digital grid, but in this webinar we will specifically focus on SIPROTEC 5 devices, which is the client implementation of EST, and the GridPass software, which is the server implementation of it. But before we talk about EST, I think it's very beneficial to remember why we need EST. And what does PKI actually mean for our energy automation network? And to discuss PKI, we need to first understand what a digital certificate is and how it is exactly signed. So let's start with a couple of prerequisites whenever you hear about HTTPS or TLS, and there's cryptography involved in it. It generally sounds very complex and very mathematical, but it actually is based on very simple concepts. So we need to bear in mind two fundamental properties of PKI. Public key infrastructure depends on two fundamental principles. Each party, or basically certificate, may have two types of keys. One key is private key, which only the party itself knows about, and the other key is the public key that any party in the world will know it. Those two keys have interesting mathematical properties. So let's start with the first rule that we have to remember. Any message that has been encrypted by the party's public key, let's call this party Bob, and Bob's public key is public, so it's out there for everyone, can only be decrypted with Bob's private key. So basically, that means only Bob, because he is the only owner of his private key, can decrypt the message, even though it can be publicly distributed and everyone can listen to it, but no one can do anything with it because they just see random bytes. And the second property is that about Alice, let's call the another part Alice. Anyone who has the Alice's public key can verify that a message could only have been created by someone with access to Alice's private key. So basically, this means anyone in the world, even though they don't know Alice's private key, can verify still that a message was actually sent by Alice. So because remember that only Alice knows his private key. So those basic two principles construct the foundation of so-called public key cryptography or infrastructure. You can use these terms interchangeably. And based on those cryptographic characteristics we discussed, digital certificates, which are basically simple formatted plain text files, are signed and distributed across the public domain. And the parts which are private are secured accordingly. In very practical view, certificate authority is the main trusted entity in the public domain, which signs the certificate of an entity that offers the servers. In example, a server which provides web page, web server, etc. But for the time being, let's not get too technical in details, and let's see how it works in our daily life. For example, when you fire up your browser and you navigate http://cmas.com. So let's start with your browser, and let's say you want to access cmas.com. The first thing your browser does, it tells to the internet directly, give me cmas.com. This is, of course, very simplified, but in essence, your computer says, give me cmas.com, and cmas.com will then respond saying, sure, here's my certificate, and this certificate contains my public key. And by the way, the certificate was signed by Amazon Certificate Authority for the next 3 years. And then your browser says, okay, I know, and I trust Amazon Certificate Authority, and I also know its public key. So I will verify whether this certificate was really signed by Amazon Certificate Authority and check if the time span is valid as you claimed, 3 years. And then your browser says, hey, cmas.com, I trust the Amazon Certificate Authority, and it looks like you are indeed who you say you are. Since I trust you, I have created a new secret key, completely random, and I have encrypted this key with your public key. So remember, if you encrypt something with public key, only the owner of a private key can decrypt it. This was the real one from the previous slide. So then cmas.com says, okay, very smart choice. Only I have my private key, so I can decrypt this. So now I have this new secret that you just randomly created as well. So then both parties realize that we are the only two machines on the entire world who knows this new secret key. And from now on, let's encrypt all of your communication with this new key. And based on this principle that we have just trusted before, we have now created a secure communication channel between your browser and the server, in this case cmas.com. Even the entire communication was public and someone could have listened to this. And a potential attacker would have seen that a message was encrypted, and since the attacker wouldn't have the cmas.com private key, they couldn't do anything. He would be just seeing random bytes. So far, we have only shown what we can communicate in an encrypted and how we can communicate in an encrypted fashion. Even though the communication channel itself might not be protected, everyone can listen on it. We already talked about how you make sure that the party that you are talking to is actually who they claim, and they are. And this is where the certificate authority comes in. And remember, we had a certificate that was signed by the Amazon Certificate Authority, but the question is, how do you get such a certificate and how it is exactly signed? So let's focus on those questions. So let's start with cmas.com web server. And we want to secure this web server with HTTPS, but we don't have anything along those lines yet. Also, there is this Amazon Certificate Authority, which is considered a trusted certificate authority. As any party involved in public key cryptography, the Amazon Certificate Authority has a private key, and of course, a public key. If the web server running cmas.com and also wants to take part in HTTPS encrypted communication, they also have to create such a new key pair, and anyone can create a new key pair. And this CMS.com web server creates a so-called certificate sign-in request. This request that CMS.com web server creates, which is made from their key pair, and basically it requests the certificate authority to sign the certificate that to CMS.com web server says, I have now decided that I want to use HTTPS from now on, and I have created that certificate signing request with my key pair. Amazon Certificate Authority, can you please sign it? So that's the workflow where how you handle the CSR or certificate signing request. And then Amazon Certificate Authority will reply, okay, I have signed your request with my private key. So anyone who has my public key can verify that it was actually me who signed this. So when the CA certificate is installed to your browser's trusted certificate storage, it can now verify that this public key, which claims to be signed by Amazon, was actually signed by Amazon, because it knows Amazon's public key from their certificate and can now reliably determine that information in the certificate that CMS.com has provided is true. As long as we trust the certificate authority, that means that public key that is in there, and we will use HTTPS to encrypt in a new secret key that we can then use for symmetric encryption. At least if we trust the certificate authority, and this trusted certificate authority is a good way to prevent a man-in-the-middle attack, for example, where an attacker could otherwise pretend to be CMS.com using their own private key pair, and then you would think that you're talking to CMS.com, but you're actually talking to the attacker. However, that wouldn't work because the attacker won't get their certificate signed by the certificate authority. That would be a self-signed certificate. In case you have your own energy automation, not like a public web server like CMS.com, but you have your own energy automation, it is current, let's say, and it's currently deployed to your running environment. If you say, now I also want to encrypt all the communication within this network, you have to create, of course, again, a private key and a public key. The next step would be now to create a signing request. But who will sign this if there is no certificate authority, because it's your private network? In this case, you can create a second pair of keys, and basically by having this set of keys, you just created your own very certificate authority, specifically for your organization. You can now do the same procedure as before. You create your certificate signing request and send it to certificate authority. The authority will make sure that you actually are the person who you claim, and check your authorization and say, here is your certificate, and it was signed by me. And again, anyone with my public key can verify that it was signed by me. The browser or the client for the communication, let's say Dixie, this time comes along, okay, I want to interact with SIPROTEC 5 device that we just deployed. The client realizes that your SIPROTEC wants to use HTTPS or TLS. It looks at the certificate and finds the public key of the device in the tree. So this certificate now says, I was signed by our own certificate authority. And then, of course, your client trusts the certificate authority that you just created. And then says, oh yeah, that matches us. As long as we trust the certificate authority, we can use HTTPS TLS here from now on. The process is really the same as with a certificate authority that was signed by a known authority, like Amazon Certificate Authority, or you name it. But the actual concept here is delegating the trust to a central authority, which is the certificate authority, and operating it as the trust anchor of your company. So with all those said, this was just an introduction to PKI to have an understanding what it actually stands for. As long as your network has a trusted entity, all the communication over TLS can be secured, which provides confidentiality, integrity, confidentiality, because no one can monitor the data transmitted over this channel, which is public. Integrity, because no one can manipulate the data that is being exchanged because it's encrypted. So let's look at how to configure a device where you already have a trusted certificate authority. In this example, we will focus on securing the communication between the client PC and the web UI of SIPROTEC 5. This type of application is exactly the same process what we have already discussed with Siemens.com. But this time, it is the SIPROTEC 5 device which is being a server. To secure the connections that were sent to web UI service of SIPROTEC 5 device, one must replace the existing self-signed certificate in the device with a server authentication capable certificate, which is signed by a trusted certificate authority. In real-world application, your trusted certificate authority will be most likely the one published by your own company, by the related security organization. Therefore, during the commissioning of SIPROTEC 5 device, so the certificate signing request file should be downloaded. This particular file consists the metadata of the service that is available in the device. We are talking about web UI. For web UI, it holds the information of the serial number of the device to verify the identity, and the IP address plus port combination of the service which is running. Then, as expected, the Csr file is delivered to the certificate authority, and then the certificate authority checks the information on the Csr, of course, and digitally signs and approves it for a defined validity of time, and provides the signed server certificate in X509 format. At that point of time, the web UI service is authorized to serve securely to the client, but of course, we need to upload this to the device. Now, as a final step, this new signed certificate must be installed back to the device. After the device successfully imports this file, the web UI will be served securely with its new certificate approved by the authority. So you might tell this step is the minimum commissioning activity that needs to be done to secure the service. But there is also operational activity that must be considered to have a secure network. Remember that the CA signs the CSR for a defined period of time. So one might think, why does the CA signs the certificate for a time frame that will expire? That's due to the fact that the cryptographic methods used in the signing process, if the necessary amount of right hardware for the right amount of time utilized, can be cracked, basically. Therefore, to mitigate those risks, each PKI environment has an operational responsibility to update the signatures in the certificate, which is called rekeying, or depending on the operation, the resigning process. The amount of time that the CA chooses for the validity depends on the cryptographic methods used in the signing process. But we can, of course, safely assume that as 90 days, typically. So if you want to express 90 days, typically, which means that this operation of downloading CSR, signing it, and sending back to the device should repeat each 90 days, practically 3 months. And this is the exact point where things get a little bit hard to manage, and EST comes to rescue. EST, as the abbreviation, stands for Enrollment over Secure Transport, which is the standardized way of handling this by IEC 62351. And as the name suggests, it is a protocol where the certificate sign requests are sent to a central EST server. And the EST server receives those requests and processes them with the certificate authority automatically, and responds to X509 certificate to the SIPROTEC 5 device. You might as well notice that this is the exact same procedure we mentioned in the previous slide, but with the difference is that it's now completely automatic. IEC 62351 heavily uses TLS connection to secure communication for a given service. Therefore, the more services you have in SIPROTEC 5 device, the more processes of handling the CSR signing request gets hard to manage. Because we should remember that CSR is necessary for each individual service, let's say web UI, Dixie, MMS, you name it, for each individual communication port of the device, so port J, port E, port F, etc. The beauty of EST is all of those services can be automated in one single EST service in the device, and the effort required to it is only commissioning stage. Once the device is commissioned, all of the devices are ready to operate the PKI with the configured renewal time. The signing process will be done automatically. To have a better understanding, I would like to visualize this for an example grid operator. So let's assume that we are a small-sized grid operator, and I have 20 substations, and each of those 20 substations have 12 feeders. I want to secure the communication for remote web UI, remote DXI, and remote MMS access, and local DXI plus web UI access, which is very common. This practically means that I have two different communication modules in the device, one for remote, one for local access. And if we summarize this, I have total 5 services in one single device. Here, let me enable my pen, if you can see it. Web UI, DXI, Web UI, DXI, MMS. So total 5 services. And 24 devices for the one single substation, considering that I have a redundant protection scheme in each feeder. So if we assume, in a very optimistic way, securing one service in one single device would take 10 minutes, this whole CSR download, sign, and upload back to the device process, let's be optimistic and assume that this takes about 10 minutes. So that would end up 1 hour per device because we have 5 different services. But if you were to use EST, it would only take 10 minutes because in case of EST, it's only enough to only commission one single service. The rest of the services will be activated by EST automatically. So for a substation with 24 devices, this would lead to a commissioning time of approximately 1 day. But in case of EST, it's around 4 hours. Even in the commissioning stage, the benefits of EST is obvious, but the real picture is more clear when when the devices are commissioned and we go to the operation stage. So we have 20 substations, and let's look at the annual operation cost of managing a PKI infrastructure. We have talked about that the certificates needs to be renewed. Let's take 90 days, for example. This practically means that each 90 days, if there is not such an enrollment automation like EST, the commissioning effort for securing the services needs to be repeated. This can bring a very heavy burden in terms of operation, because even in the case for a small grid with 20 substations, this would mean a total of 3 months of effort for annual yearly operation, or in other words, a quarter of the years. So I think from that point on, the question is not what is the benefits of EST, but the question now is it even possible to manage the certificates in the grid without EST or something similar like EST? In that regard, as soon as we think that it is maybe possible for small operations, but definitely not scalable for mid or large size grid operators. So let's take a brief moment and look at those numbers again. I think the picture is very clear now. And also we didn't talk about the other risks which may cause to block access to your running substation, and the burden of logistics and operability of the maintaining certificates renewals. So commissioning one device takes around 1 hour without EST, and if we do with EST, it takes only 10 minutes. And the operating burden is 1 hour, let's say one single device, but with EST it's nothing because it's completely automatic. And let's take 90 days renewal policy, which is pretty common. And we have 12 feeders per 20 substation. This would conclude to 20 days of commissioning days for 20 substations in the grid. And on the contrary, if you were to use EST, it's only just 3 days. But it's heavier. There is a heavier cost when we try to operate the grid without EST, because each, let's say, 90 days, we have to renew all of those certificates, and that would approximately require 3 months to really manage it. But with EST, you just don't have to do anything. It's done automatically. Therefore, at Siemens, we are very proud to be the early adopters of EST protocol as a part of IEC 62351 and offer a complete solution both for the server and the client implementation of EST. In our current offer, GridPath software acts as an EST server where your substation devices will connect to. With the intuitive UI that GridPath provides, it's definitely 5 clicks away to enable EST. But GridPath is not only limited to just an EST server. With GridPath, you can also create certificate authorities or individual client server certificates with just 5 clicks. In addition to 509 management, GridPath also can manage the RBAC user tokens, which is required for IEC 62351 RBAC models. Also, let's have a small review of the benefits of EST here. So, the basic advantage of PKI is that you don't have to use manual pre-shared keys anymore, because now your credential management is based on the pre-imprinted certificates. The private keys are secured by security administrator, and your authenticity is basically managed by the certificates. With the EST, your PKI environment will be 100% secure. And the best part of it is that it's scalable now. Without EST or any kind of automation, the more devices that you need to secure you have is the more burden you have to carry as your SecOps. And one other thing is that we should also remember that 62351 is the one who is standardizing EST. So it's interoperable and an open protocol, not limited to Siemens design only. And last but not least, with EST, there is no room, or let's say less room for human errors, and it's completely automated. But don't take my word on it. So let's have Dr. Simon on the line to show us how this works in digital twin with hands-on training session. He will use digital twin to simulate SIPROTEC 5 devices and use EST to automate the certificate for web UI access. So Simon, back to you.
Yes, thank you very much, Hussein, for this tutorial about automatic certificate enrollment, and welcome to the practical demo. The device where EST is implemented is our SIPROTEC 5 protection and control device, and I will use the digital twin of SIPROTEC 5. Let us open this digital twin with my browser as a cloud application. It's the same as a real device on my desk, but it's in the cloud, the simulation of the twin of the relay. The digital twin allows to familiarize with all the functionality without effort to upgrade hardware or software or cabling. So we can access this device like a real device, for example, with a browser to access the web UI, or with the engineering tool called Dixie 5, for example. So let us look in the web UI. So for the web UI, I have to access on the IP address with the port 444.3. And here we can see under certificates, certificate in use. One moment, please. Here, certificate in use. Here we see We can find the services, so the services Dixie and the web server, also for all the ports with a self-signed certificate available. For example, the web server here, it's have a certificate self-signed by the device. So let's go back to the slide. So our goal is to replace this self-signed certificate with a certificate signed in our own CA. For this, we need a public key infrastructure. And we at Siemens Energy Automation, we develop an application for energy automation engineer to create and manage certificate easily without having high IT knowledge. This tool is SICAM GridPass. No, we do not want to create manually certificate for each secured protocol. We will to use the automated way via the EST protocol. So SICAM GridPass is a server and the device is a EST client. The state of the art to secure this protocol EST is TLS. So we need an X509 certificate to ensure this client server authentication. Let us open SICAM GridPass. So and see some settings for the EST server. So we can see here under the settings that we have here. The example before GridPass, and said here's a number of days what we want to refresh the certificate. For example, here is 90 days, and we also here set the CA that will sign this certificate. So back to the slide, the commissioning workflow is like that. The first step is with Dixie, we configure the device with activated EST client. And in the same step, we load the CA that have signed the EST server certificate. The step 2 is to export the Csr file from the device. And in the next step, we import this in SICAM GridPass, the Csr, and sign it with our own CA. And then we will get the certificate as a PEM file. And then, last step, we import the PEM file in the device. And then for the configured protocol, via encrypted communication and Csr signing request between the device and SICAM GridPass, the certificate will appear and replace the self-signed certificates. So let's do the first step in Dixie. Here I can open my Dixie. I have here for the device, here under safety and security, I can see here the automatic certificate management. And I see in background my connection to my VPN, well, the VPN to my digital twin is broken, so I have to switch to the slide. So don't worry about that. So I have to enable EST server, set here the IP address of my EST server and the port. Okay, the standard port is 8085, and the port J where on the device can be used. And I can then also set the trusted CA, the GridPass CA2030, And here I also have to set which kind of protocol or service I want to enroll. So let me show if I can restart my digital twin in the background. Hopefully it works. Either it's not so problematic. So normally when I do that, then I load, right click, and load the security settings to the device. I can do that when the device is restarted. So let's wait a little bit. So as said before, the next step is then look at here on my slide that we do. The next step here, we have to load the security to the device. And the next is to go to the SIPROTEC 5 web UI and under certificate, requested certificates. We can see then that the we have here under EST integrated port G, we have the possibility to export the CSR file. Click on export CSR, and we get then the ESTJ CSR file. And the step 3 was now under SICAM grid path to import the CSR file. So under certificates, we import the CSR file, and then we choose this file. And then we have this picture where we can select the CA for the new certificate, or a GridPath CA 2030, for example. And then we can set next, and you will see in this GridPath that you do not have knowledge about all the keys what you can set in a certificate. This is already pre-selected to don't do any error and to get a real certificate. So then click on OK, and a PEM file is automatically exported in the download. With this PEM file, we can in GridPath, we also can see that this under certificates, that this certificate was created with information what was in the CSR file for my device, for the port G, for the protocol EST. So now in SIPROTEC 5 web UI, I can import the EST client certificate. Under certificate in use, I have the button to import. I select the PEM file, here, for example, also from my download, and then we will see under certificate in use, that we have now also the certificate signed by our CA and with validity and the serial number of the certificate, but also it's valid for the serial number of my device, what I have get from the CSR file. So with that, when in the background the communication to the SICAM grid path, in the next step you will see that SICAM grid path have created the certificate for the port E, port G, and USB for the service web UI. And inside the SIPROTEC relay, you can see that we have the web for the web server exactly a new certificate with a duration of the 90 days, depends on what you have set in GridPass. And now we have this certificate created automatically, and during the lifetime, also the certificate will be replaced. So I'm finished with this short demo where we have seen how easy it is to create an EST communication between a comprehensive public key infrastructure like GridPass and a protection device, SIPROTEC 5, can be easily simulated with a digital twin. So let us go now to the Q&A with Hussein.
Thank you, Simon, for this detailed hands-on session. Meanwhile, I was checking the question sessions. We have a lot of questions, so I would like to start with the first one. DN asks that what will happen if the EST server is not available for some reason, server dump, communication problem. So the commissioner should wait. So the process is like this. In the commissioning stage, it's on demand. So whenever you have an available link, you can utilize EST to really be a proxy for the rest of the signing process. But in the operation, if the question is about the operations, the renewal time is the last 3% of the time frame of your renewal time, and a random time in this is the 3% renewal time. So let's say you have 100 days of renewal time. In the last 3 days, at a random time, the ST server, the ST client in SIPROTEC 5 will ask the ST server to renew the certificates. And then, if it fails, it will retry again. So you have 3 days to fix your network, and I think this is a proper way of doing the application. And I would also interpret the same question in terms of redundancy. Unlike the OT protocols, it's not a very good idea to have a redundant EST server, because the whole concept of your security is to have a central trust anchor. At the moment that you have redundant trust anchor, this is not easy to manage in the mid or long term. That's the first question I would like to answer. Second question. EST server is working on localhost or is web-based? So I think Dr. Simon, you can maybe.
Yeah, EST server is work on web-based. So yeah, you can set your EST server everywhere in your web network. Take care on firewall rules, open the port. Normally it's a port 8085, and so yes, use it as another protocol in your network.
Mm-hmm. I have a lot of more questions. Maybe I can go on from now on. It's clear the way how to manage a PKI with the EST, but how does the process without EST work? So that's a great question. I think we had a poll question about it. If we haven't already, maybe it's time to ask the audience to you. And meanwhile, I can share my experience. So in IT world, it's basically the user's responsibility to renew it, because to do it centrally for a big organization, it's not very practical. So the security organization says you have to renew your, let's say, badge or certificate in a defined period of time. But this does not really fit the operation intensity of mission critical networks like an energy grid because in case the user has forgotten to do it, then the consequences are dire. So you have to then the user wouldn't have any other option to log into the device, and that would create such DOS situations, let's say. The second approach that one must take is to automate using scripts, but this is not 100% perfect secure in terms of security, because when you do the scripting, you have to do client-side automation, which is prone to errors. it can be done, but it is print errors, so it's not the perfect way to do it. So from my point of view, it's really essential to manage the PKI with an automated in an automated way. And the best way to do it is to follow the standardization of IEC 62351, which is EST. Maybe I can take up this question as well. MH is asking, if the certificate is compromised, what is the way to protect the automated device? So I think the question is, what if the certificate private key is compromised? And so in this case, we have CRL listing, certificate revocation list, and it's embedded in the certificate attributes. So when you can also do this with GridPass, but in your central server, where your CRL is distributed, you can add this serial number of the certificate to your CRL list, and the certificate will be automatically revoked if you don't have the trust. So after that point, device will request another CSR to the EST server and create a new certificate. By the way, at the moment of time, the CRL support is not yet implemented in SIPROTEC 5. We are expected to implement this in the upcoming versions in next year, 2022. So another question, how do I get automatic certification option? So it's completely free. It comes by default if you install a firmware greater than 8.60 in SIPROTEC 5. There is no consumption of function points or anything. It doesn't really depend on the product code as well. Does it mean all installed base, AA is asking that, does it mean all installed base device service certificate will expire after 90 days? Is it mandatory to inform such a certificate renewed note to the customer? So it's up to the security administrator policy. But as said, if you can use a renewal time up to 2 years or 3 years, if you use a signing algorithm, which is strong enough. But the stronger your algorithm is, the harder it is for device to process. It may work for, let's say, PC based, where your installed base has a huge CPU power, but for end-to-end machine-to-machine communication or the embedded devices, it's practical to be conservative about the signing process. So another question from DN. Does the PM file stored in the SIPROTEC 5 device in a secure manner, TPM module or other secure methods? So great question. Thank you for bringing this up. We have a crypto controller in SIPROTEC 5 devices where your private information are stored. And upon this crypto controller, we have implemented a secure storage module inside the flash drive of the device. So it's not 100% TPM, but we have a very good secure storage in the device where we store the user-sensitive data, say PAM file or pre-shared keys or any kind of private information. And last question that I could take is that the certificate got expired. Does the MMS service on the installed device will be stopped with respective SCADA? Yes, that's the idea. So these are the questions that I could identify. Simon, maybe you have some other questions that you could see?
No, I don't see other questions. Okay, about cost, you also talk about.
Mm-hmm.
Okay, other questions. Another question I see is from HK is SICAM GridPass available as a demo version? And yes, you can use SICAM GridPass as demo version to familiarize with it, to to practice this is a demo version. The certificate you will create is only valid for 30 days or something like that. And so look on our homepage, and you also can then try to be an IT engineer and create it very easily, your certificates.
I don't also see any other questions. If I check in detail,
last question comes up from MH. Is that the SIPROTEC 5 protocol compiles the standard of ICS-OT standard? Hussein, you...
Maybe I can take up with it, but to be frank, I don't have the exact information about this standard. We are very confident about the standardization support in our devices, but I will take this up with me and contact you via email, because I don't have the exact details of ICS-OT standard. So I think we can close the session. We are out of the questions.
Yes, okay. So, dear auditorium, thanks a lot for your question, and thank you to Hussein for all your answers. Still open questions, the Q&A queue will be answered by email. And if any questions come to your mind later, please contact us. The access to the recording and the slide will be sent to all participants. In the upper right-hand corner, you find the presentation for download. As the download area is not visible in full screen mode, you might want to press Escape. Thank you very much for active participation. It was a pleasure for me to guide you through this hands-on session on automated credential management with ICAM GridPass and SIPROTEC 5. Stay safe and sound. Take care and goodbye.